Now, back in algebra, we learned about slopes. So now we're going to do a quick review to see what we remember. So a slope of the line that is going up and to the right, we call positive. It's going to have a positive slope. If it's going down, it's going to have a negative slope. If it's straight horizontal, it has a zero slope. So that means when we look at the slope, whatever in the numerator, we have a zero. And then a vertical line, all vertical lines, the slope is undefined. And that's because we have a zero in the denominator. And we don't know how to divide by zero. So it's undefined. So we either have a positive slope, a negative slope, and we always look at it how it's going, moving towards the right to determine whether it's positive or negative. Zero, if it's horizontal, and up and down or vertical, its slope is always undefined. So let's look at some more examples of how we find the slope. Well, the first way we have to find the slope is by using a graph. And when we have a graph, we're going to use m, and we usually use m for the slope. We're going to do rise over run, which is rise, rise over run. So here we're going from A to B, and we've got 1, 2, 3, 4. So it goes up 4, and it goes over 1, 2, 3, 4, 5. So m equals 4 over 5, rise over run. Now let's look at number 2. Now the rise, as you can see, it goes 1, 2, 3. It goes down 3, so that's a negative 3. 1, 2, 3, 4, 5, 6 over 6. So m equals negative 3 over 6, but as we all know, we can reduce that down to negative 1/2. Let's keep going. Here, we have a vertical line, right? The rise is infinity, and the run is 0. Rise. So m just equals undefined. So naturally, if we have a horizontal line, m equals 0. And that is our slope when using a graph. And I know you all remember this, but we're going to go over it anyway. If we have an ordered pair, right, we have points A and points B, we're going to use the slope formula, which is what we use for our slope, y2 minus y1 over x2 minus x1. So the change in y is the rise, and the change in x is the run, just like we did here. Rise, run. There's the run. There's the rise. But here we got points and not a grid, so we need to take some mathematical steps to get there. So m equals y1 or y2 minus, let's do it this way. There's y1 minus y1. Let's get my colors right. Y1 over x2 minus x1. And you'll notice that these two are these two, and these two are these two. And you want to keep them together, because if we were to write it y2 on top, if we wrote it like this, where we crisscross them, we will be in all kinds of trouble because it won't make any sense at all. So let's make sure we don't do that. Keep the two together. So then we're going to have minus 6 over 8, which equals negative 3 over 4 once we reduce it. And we found m. Let's move down to our next one. So we're still dealing with y2 minus y1 over x2 minus x1. So m equals 7 over negative 6. So my x and y minus a minus 3 minus a minus 11. So my x and y's are lined up. So 7 minus a minus 3 is plus 3, so that's 10. Negative 6 plus 11 is 5. So my slope for this one is 2. Number 7. So x2 minus y1 over x2 minus x1. So I get 2 minus a minus 4. M equals, and 9 minus 9. And you can see where this one is going. So I got 2 plus 4 is 6 over 0. I can't have 0 in the denominator because I don't know how to do it. So M is undefined. X never changes. We have a vertical line. Minus 3 minus a minus 3. And you can see where this one's going to. M equals minus 3 plus 3 is 0 over 7. M equals 0. All right, so let's do some practice. Let's do some practice. Let's go with the grids first. So we got M equals 1, 2, and then 1, 2, 3, 4, 5, 6. 2 over 6, well, we know we need to reduce that down, and it's 1 over 3. So here we got M equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10, because we're dropping, and then 1, 2, 3, 4, negative 10 over 4, which equals negative 5 over 2, and we are done. Number 3. 1, 2, 3, 4, 5, 6, 7, 8. M equals 8. Our run is 2, 1, 2. 8 over 2 equals 4. So M equals 4. These are fun. Let's do a couple more. Here, our rise is going to be negative because we're dropping. So it's 1, 2, 3, 4, 5, 6, 7. So M equals negative 7. And the run is 1, 2, 3, 4, 5, 6, 7. also 7. So m equals -1. Here we have a horizontal line, and we know horizontal line, m equals 0. All right, here we got 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 4 over 7, which does not reduce, so m equals 4 over 7. All right, let's do a bunch where we're using the slope formula, which, as I'm sure you recall, is y2 minus y1 over x2 minus x1. So m equals 4 minus a -11 and 17 minus a -8. And as you can see, these guys are here on top of each other. These guys are here on top of each other. So 4 plus 11 is 15. 17 plus 8 is 25, which is going to reduce down to 3/5. M equals 3/5. All right, let's see what we got here. We got M equals -17 here minus a -15. Then we got 13. Yep, minus 10. So -17 plus 15 is -2. 13 minus 10 is 3. Does not reduce. M is 2/3, -2/3. Let's look at a couple more examples. M equals -7 minus a -7. And you all see where this is going to go. 5 minus a -6. So that's a plus, that's a plus. This is on top of each other. That's important. -7 plus 7 is 0 over 11. M is 0. I can make a better 0 than that. There we go. Let's see what else we can make happen. M equals -9 minus a -3 and 2 minus a -4. All right. So 9 plus 3 is -6. 2 plus 4 is 6. M equals -1. right, so we got 5 minus a minus 2 and 10 minus 10. And we can all see where this is going. So we get 7 over 0. We don't know how to divide by 0. So it is undefined. Number 12. And 19 minus negative 5. Let's make sure I'm set up right. So we get negative 9 over 24, which reduces down to negative 3 over 8. Negative 16 minus a negative 12. And we get 1 minus a negative 7. Okay, we got it set up good. Rm equals. So negative 4 over 8 equals negative 1/2. Couple more examples. All right, so let's double check. Negative 13 and 1, negative 13 and 1. So we got 1 over 5. That does not reduce, so we are done. Let's figure this one last one and we'll be done for today. Negative 4 minus a negative 11 over negative 2 minus 1, negative 2 minus 4, negative 2 and minus 4. So we get 7 over negative 3. That does not reduce, so we are done.